Let's talk more about isotopes. If you remember in a prior video, isotopes are atoms of the same element with the same number of protons, but different number of neutrons. So in this problem, you need to identify those isotopes that are atoms of the same element. And in another video, I talked about the nuclear arithmetic for isotopes. So looking at these annotations here, you see a subscript and a superscript. And the subscript represents the atomic number of the element, or the number of protons. And the superscript represents the nucleon number, or the number of protons plus neutrons. So based on that information, if you look at the first and third element noted here, which is this one and this one, you notice that the subscript is 20. So that element has an atomic number of 20. So they have the same number of protons. Now, if you look at the fourth and fifth element here, they both have the same subscript, which is 16. And that's the atomic number, which is 16, or the number of protons. Now, if you look at the periodic table of elements, let's go find out what element has an atomic number of 20 and what element has an atomic number of 16. So here's the periodic table of elements. Calcium has an atomic number of 20, and sulfur has an atomic number of 16. So now that you've identified those isotopes, they have the same number of protons. If you look at the second element, it has an atomic number of 30, and none of the other ones have an atomic number of 30. So basically, you can easily say that this one is not an isotope. So you can cross it out. Easy as that. Now, once you identify the isotopes that are atoms of the same element, you need to determine the number of neutrons for each one. So now that we figured this out, let's look at this a little bit more. So if you look at the first element, so we'll put a 1 here. Okay. So now you look at the first one. To determine the number of neutrons, if you look at a prior video on the nuclear arithmetic for isotopes, you take the nucleon number, which is 40, which is the superscript, and then you subtract off the atomic number, which is 20, and that gives you 20. Let's try this again. That gives you 20 neutrons. So that's the answer for the first element. You have 20 neutrons. Now, if you do the second problem, which would be your third element, let's put a 3 just to match up with the part up there. So if you look at the third element, you're going to take the nucleon number, which is that superscript of 44, and you're going to subtract off the 20. And that gives you 24 neutrons. Now this is more visual, as you can see. As you can see, they both have the same number of protons, which is an isotope. But look at this. They have a different number of neutrons, which is the 20 and the 24. So those are isotopes right there. And what did we say this one was? We said the element with atomic number of 20 is calcium, Ca. There you go. Now let's work on the other one. So we'll erase this right here. Now, Let's go ahead and look at the rest of this problem. If you look at elements 4 and 5, so let's look at number 4. So now we're looking at this. We're going to have to take the difference between the nucleon number and the atomic number. So looking at the 4th element up here, we take the nucleon number, which is 32, and you subtract off the 16, which gives you 16 neutrons. Now, let's look at the 5th element up there. Once again, take the difference between the nucleon number and the atomic number, which is 34 minus 16, which gives you 18. Now, look at this. So, looking at the 4th and 5th element, they have the same number of protons, which is 16, but they have a differing number of neutrons, which is the 16 and the 18, which makes them isotopes or atoms of the same element. And what did we say this element was with atomic number of 16? The element is sulfur. And that's isotopes in a nutshell.